Okay, next, let's do the second extension of the language to support functions. The new grammar will be extended like this. Okay, first function names. Okay, this one can be expressions. Okay, and then we have function call command like this and return command. Okay, and also function definition here with a parameter and a function body. That is a sequence of commands. Okay, and a program P is a sequence of function definitions and sequence of commands. Okay, so in this lecture we assume the following things. So there's no nested function definitions like in OCaml, but all the function definitions are flat like in C. And also for simplicity, we consider the parameter as the only local variable for a function. All the other things are global. Also, function names are first class values, which means that function can be called using different aliases or through different expression evaluation, as you can see here. This E rather than just function name. Okay. And last, every function has one parameter with a unique name. Okay. Let's see how a program is executed with a simple example. Okay. Here is a recursive function called sum that computes the sum of all integers between 0 and a given positive integer x. Okay. And a function call to the function with parameter 2 here. Okay. Then let's see how it works. Here is a diagram that shows the memory snapshots during the execution. The down arrow, okay, down arrows are function calls, and the up arrows are returns. Okay, and each number represents the call depth at that moment. Okay, so the program initially calls sum of 2, right here. Okay, and then what happens? The memory becomes like this. Okay, after parameter binding, x maps to 2 in the memory. Okay, and then because x is now not 0, so we get into the fourth branch. Okay, and call the function again with new argument 1. Okay, then the x entry of the memory becomes 1. And then we keep going. Okay, and another recursive call with argument 0 will happen, right, like this. Okay, then it get into the true branch now. Okay, and do the assignment to global variable c, and then we will return. And then after return, the execution have to restore the old memory entry of x here, right? What does that mean? In the last function call, x was 0. Okay, but after return, x should be restored to 1. Okay, x was 1 before the last function call. Okay, and then it updates the entry of c in the memory like this. So x, the value for c becomes 1 now. Okay, and we do the same thing for the next return. Okay, and then finally return from the first function call. Okay, after that, in the output memory, c maps to 3, right? So that is the execution of this program. So as you observed, there are some new behaviors that are different from the old ones, like call and return and restoring the old memory and so on, right? Then how do we define and abstract this program execution with function calls and returns? Okay, that is our question. So let's clarify these things. Which means what components are actually needed to support function calls and returns. Okay, we can come up with two fundamental questions. So you can see the first one is that there are multiple instances of parameter x for each call, right? Even with same location, right? Then how to distinguish the current instance of x from the others, okay? And how to abstract them. That is the first question. To handle such a problem, we will use a mechanism called environment, okay, that determines the current instance of the parameter. Okay, this will be added to our semantic domain, right? Environment. The next question is that there are multiple function calls to the same function, right? Then where do we return after function calls? Okay, that's the second question. To handle this issue, we will introduce a mechanism called continuation that actually remember the return context for each function call so that we can return to the right destination. Okay, that is the second point. Then let's define the concrete domains. Okay, this extension is orthogonal to the previous extension for pointers. So for simplicity here, we don't consider any pointers. Okay, here is the definition. A state, okay, is a tuple of 5 elements. Okay, label is the same as before, and memory, okay, and environment, and continuation, and instance. Okay, let's take a look at each component one by one. A memory is a mapping from memory address to values. Okay, a memory address is a pair of a variable and an instance. Okay, which means that here each variable is associated with an instance to distinguish different instances from different function call. Okay. Then what is instance? So here we use instance, this instance. Okay, an instance is a timestamp, a kind of global counter that ticks at each function call. Okay, so that we can differentiate variables with the same name based on the different instances. Okay, and the next one is an environment here, this one, okay, which is a mapping from variables to instances. Okay, it provides the information of the current instance for each variable. So for each function call, we will make a new environment. Okay, you can think of how a conventional program execution makes a new stack frame to make a new environment for local variables. Okay, the next thing is continuation, which is a list of a pair of a label and an environment. Okay. The label this label represent the call site, okay, and this environment represent the environment at that call site, which means before the function call. Okay, this gives the information of where to return by this label, the restored environment after the return. Okay, conceptually it is similar to call stacks of conventional program executions. Okay, and then finally let's see the value domain. Okay. Here now the function is also a value. You can assign a function to another variable and pass to a function as an argument, like high-order functions in OCaml or function pointers in C. Okay, that is our concrete domain. Then let's see how the example program is executed with this concrete domain. Here is the same example, and we have 4 components: memory, environment, continuation, and instance. Initially, it starts with the empty memory, okay, and initial counter 0 as the initial instance. And we have one global variable c. So because it is a global variable, we have only one copy of this variable associated with this initial instance 0. Okay, and there is an empty continuation initially. First, it calls to the function sum with argument 2. Okay, so the following things happen here. This program first takes the global instance by increasing the number by 1. Okay, then make a new element in the continuation after function call that consists of a label which is 11. Okay, that is this call site. Okay, and the environment at the function call. Here for simplicity I omitted the environment, but the old environment is stored in the continuation. Okay, and it make a new element in the environment also. Okay, that is a mapping from the parameter x to the new instance which is 1. Okay, then finally update the memory of this entry. Okay, entry of the first instance of x that represents the new instance of parameter x at this function call. Okay, the value is 2. Okay, and then the execution gets into the first branch because the value of x is not equal to 0. Okay, then next it calls to the same function with a new parameter which is 1. Okay, so what is going on here? So the program takes the instance, right? So the instance becomes 2. As I mentioned, for every function call, the program takes the instance and increase this number by 1. Okay, and it makes a new element in the continuation. Okay, here this new entry 6 is added because the function call happened at label 6. Okay, and also I omitted that the old environment is stored in the continuation. And make a new element in the environment. Okay, here the instance of variable x is now 2. Okay, from now on x represent the second instance of x. Okay, and then it updates the memory properly. Notice that it does not update the first instance of x, but it adds a new instance of x. Okay, and then again the execution gets into the first branch and another recursive call happened, so all the similar effect will happen. Okay, this time this execution gets into the true branch, so the memory entry for variable c will be updated accordingly, as you can see here. And next the execution should return from the call because of this return statement. Okay, but the question is where to return. It depends on the continuation. Okay, it first look up the topmost element in the continuation. Okay, that is the latest call site, that is line 6. Okay, so the execution goes to the next label of the call site, okay, which is 7, line number 7. Okay, and then the global variable is updated. Okay, but notice that when returning, the old environment is also restored. Okay, so here variable x means the second instance of x. Okay, it will use number 1, the value of x. And again, another return will take place and the value for c will be updated. Okay. And finally, it exits from the oldest function call. Okay, based on the element in the continuation, it returns to the next label of number 11.